Today we're going to be doing the same thing that we did for the past 2 days, finding trig ratios and solving trig equations, but this time with non-special angles, which means we're not going to be using our unit circles. Our unit circles only pertain to the special angles. We're going to be working with ones that, you know, we can't do on our own, but our calculators can do it, so that's why I passed out calculators today. So let's go ahead and get started. The first type of problem that I want you guys to know how to do is how to find the trig ratios. So let's take a look at example 1. Find sine. Well, you know, instead of writing all those out, I'm just going to put find all 6 trig ratios just to kind of keep it easy. I'm going to do 2 problems. I'm going to do one in degrees, and I'm going to do another one in radians. Now, it's not going to look like radians, but it is. I'm just going to say 4 radians. Now, usually when we're talking about radians, that means that we have a pi in there, right? It doesn't have to. It's just that usually the number of, you know, the nice angles that we work with have pi in them, but a radian can be any number. All that means is that we have 4 radiuses. Okay, so remember your circle, right? How many radiuses fit around a whole circle? 2 pi, which is about 6.28. So that's about 2/3 of the circle worth of radians, right? So anyway. Now, the reason why we need 2 separate examples is because your calculator, you need to tell your calculator whether we're working with radians or degrees, okay? So let's go ahead and do this first. Let's do sine of 80. And you guys just punch it in your calculator. It's pretty straightforward. We don't have much work to do there. So sine of 80 is, and we're just going to take it up to the third, the thousandths place. So that is 0.984. Okay, let's do cosine as well. .174, and then tangent is equal to 5.671. That's a good question. So right now you're in the bottom right-hand corner. You should see the letters D, E, G. Is anybody seeing that? Or is anybody not seeing it? Okay, anybody that matters. I'm just kidding. All right. So you're going to push this button right here, now D, R, G. And then after you push that, go to D, E, G. Push enter. All right. Now, here's the part that you guys need to pay attention to because the calculator does all this work for us, right? Now, what if I asked you to find cosecant of 80? What we're going to do is we're going to take the answer for sine, and we're going to do the reciprocal of it. So it's 1 over 0.984. Now, our calculator can't do that for us because, yeah, you know, or if you don't want to use a rounded number, let's do this instead so that we can get a better answer. How about doing 1 over sine of 80? So here's what I want you guys to put into your calculators. Push 1, divided by sine 80, and then push equals. You should be getting 1.015. All right? Secant of 80. Secant of 80 is 1 over what? Cosine. Cosine of 80, right? So let's do that. I'm getting 5.759. Then finally, let's do tangent of 80. I'm sorry, cotangent of 80. Now cotangent would be, cotangent of 80 is the same thing as 1 over tangent of 80. It's the reciprocal, right? So that would be 1 over tangent of 80. So that's going to be 0.176. So that's how you can find your 6 trig ratio values on a calculator. Now that's with degrees. Now we're going to do radians. Now I don't think I'm going to do all 6 again here, because the point I wanted to illustrate here was how do you find all 6, and calculator does the first 3 and we just have to do the reciprocal for the other 3. The only reason why I'm including a radian example is just so you guys know how to operate your calculator. So what I want you guys to do is we all want to find the DRG button at the top left corner, second one from the left. Do you guys see it? Okay. So I want you guys to push DRG, and then I want you to scroll over to where it says RAD for radians and push enter. Now in the bottom right-hand corner of your screen, you should see the word rad. So now our calculator is going to be giving us things for radians instead of degrees. If you don't switch it, your calculator is going to give you very wrong answers, because 4 degrees, you guys can imagine what that looks like. It's really tiny. That's almost nothing. But 4 radians, that's almost 2/3 of your circle. So they're completely different things. So you got to make sure you're telling your calculator what unit you're using. All right. So let's just do one. Let's do sine. So if I do sine of 4, we all should be getting negative 0.757, right? And if I wanted cosecant, just for example, what would I do? Yeah. So 1 divided by sine of 4 would be negative 1.321, and I'll put dot, 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 or so on. I'm not going to do the rest. So we just want to make sure you know how to change from degrees to radians, and we also want to make sure you know how to find the secant, cosecant, and cotangent, since your calculator doesn't actually have those buttons. Oh, how to change it? Okay, I'll look at it and then I'll have to find it. Let me give you guys, I'm not going to ask you to do all 6. I'm going to ask you to do some specific ones, okay? So here's your student practice. Okay, so these are all going to be degrees. So I want you guys to find tangent of 305. And I want you guys to find cosecant of 216. And then for radians, now don't forget, you're going to have to change your calculator back to degrees for these ones, right? And radians for these ones. For over here, let's do cotangent of pi over 12. Pi over 12, once again, that's not on our unit circle. It has a pi in it, but it's still not on our unit circle. And that's something that we would have to use a calculator for. So, all right. And our calculators can do the special angles as well. It's just that we want to know those ones by heart at least. So, all right. I guess I won't erase those just yet. Let's go ahead and go on to another slide. So we're going to switch gears up a little bit here. So we found what I've done on this last set was I gave you the angle and asked you for the ratios. Now we're going to switch gears and I'm going to give you the ratio and ask you to find the angle. But before I do that, I have to introduce a new thing to you. Okay? Let's go ahead and start writing this down with me here. If sine of theta equals y, then theta is equal to arcsine of y. This is called arcsine. Okay? These are inverse functions that I'm sharing with you. So what's the opposite of addition? Right? They cancel each other out. The opposite of multiplication is division, right? Well, the opposite of sine is arcsine. So if you were to sine theta, and that gives you y, if you arcsine y, that gives you theta. Okay? So this is what we call an arcsine function. So next one, we have if cosine of theta equals y, then theta is equal to arc cosine. I said y. It should be, what should I have put here? X. Then cosine of x, arc cosine of x is equal to the angle. Finally, if tangent of theta is equal to, I'm just going to make a new letter. I'm not going to put y over x because it's kind of unnecessary. But if tangent of theta is equal to a, some number a, then theta is equal to arctan of a. So just to kind of bring this down to earth a little bit, I'm gonna show you guys a little example, and then you don't have to write this example down. We're gonna do more, but I just want you to kind of grasp what this means. And then after that, I'm gonna share with you something about the answers it gives. So don't write this down, just watch. So suppose I told you guys that sine of theta is equal to, let's do something we're familiar with. Let's say that sine of theta equals a half. Now look at your unit circles, and you guys tell me what are the what sine values are a half. Where are the y values equal to a half? Give me the angle in degrees, please. 30, and what else? There's one more. Good. You're using your memory, huh? 150. Good. All right. So now I'm going to show you guys something. I want to solve for theta. Now we can use our unit circle, but I'm going to show you how we can use the arc sign to get the answer. So right now I'm signing theta to get half. I want to undo the sign so I get the theta by itself. So I'm going to do the opposite of sine on both sides, which is called arc sine. And when I do that, these cancel each other out, and I'm left with theta. So theta is this. Now you do have this button on your calculator. So first of all, make sure you guys are in degree mode. So go ahead and change your calculator to degrees. I don't want to do radians right now. Let's do degrees. All right. Now what I want you guys to do is I want you to push second in the top left-hand corner. And then I want you to push sine. Now, what you should see there's not sine, but you should see sine with a little -1 on your calculator. You see that? Okay. Now, go ahead and put in a half there on your calculator. 1 divided by 2 and then equals. What do we get? 30. 30. There's our answer. So our calculator knows how to arc sine a number to give us an angle, right? So I got Justin first.
So can we get 152?
That's a good question. Hold on to that thought. Is that what you were going to ask? Yeah. Okay. So the problem is our calculator arc sine will only ever give you 1, and that's kind of why I wanted to show this to you, was to first of all show you what arc sine does. It helps you find an angle when you have a coordinate, but also it can only give you 1 answer. It can't give you 2. Now there is a way to find the other one, and I think that's what I'm going to let you guys ponder. I'm going to give you a little sneak preview. That's what your free response is going to be related to. So I'll let you guys ponder it. Okay? But in the meantime, here's what I want you guys to write. So, ranges of arc functions. Okay. Sine, arc sine, and arc tangent, they will only ever give you answers from -90 to +90. Or if you want to think of radians, from -π/2 to +π/2. Now a visual picture of that is, here's our unit circle, right? You guys should be writing this down. whenever you do arc sine, it will only give you an angle value from this half of your circle. Okay? It won't give you the one on the, there is an answer on the other side, but it won't give it to you. So for the example that I gave you, it gave us 30. Now you guys know from your unit circle though, there was another one over here, right? But it won't tell you that one. It will only give you an answer from the right side of your circle. Huh? I'll let you ponder it. I'll let you ponder it. I'll let you ponder it. All right. Now, cosine is a little bit different. Arc cosine will only give you an answer from 0, not x, I'm doing theta. It will only give you an answer from 0 to 180. Or from 0 to what? Pi. I was doing radians. All right, so now on our unit circle, that means that arc sine will only give you angles from the top half of your circle. It will not give you the answers from the bottom half. Now, I'll tell you why that is. The arc functions are functions. And do you guys remember the rule about functions? Every input should only give you how many outputs? 1. So it's not possible for a function to give you more than one answer. Now we know that on the unit circle there are more than one places where this occurs, but that would not make these arc functions functions. So they can only give you one answer. And so by limiting the range to the top half or to the right half, you end up getting the one answer, which therefore makes them functions. Okay? All right. So there you guys have it. So I don't think I gave you a title on this last slide, so I'll go ahead and write it. We'll call this A, and it's arc functions is what they're called. I didn't write the name for all of them, but I can now. This is known as arc sine, and this is known as arc tangent. Now you guys will notice that I didn't do arc secant and arc cosecant and all them. They're there. You can do those. I'm not covering them. It's just kind of like cosecant and secant, cotangent. They're almost like, why are we learning about them anyway, almost? And then to go even deeper with their arcs, it's like, nah, we'll forget it. So,
Those are 2 arc sines.
oh no, that's cosine. Sorry. Thank you. So it's arc cosine, not arc sine. Thank you.
Oh,
Yeah, sorry about that. All right, so we're going to go ahead and use these now to solve some equations, but remember it's only going to give you one, and for the required portion of your test, that's the only answer I want, is the one angle it gives you. But for your FRQ, I think this is what your FRQ is. I think. I don't usually tell you in advance, right? I want you guys to think these things, but I'm giving you a sneak preview. I think it's where there's a way you can figure out the other one, okay? But I'm going to leave that for your food for thought. Let's go ahead and do example 2 now. Use arc functions to find a solution. Bless you. So let's do an example here. Suppose I gave you guys tangent of theta is equal to, I don't know, let's say -3. Okay, now there's no -3 on our unit circle tangent values. We have radical 3, right? But not 3. Which means we can't just figure this out. We need our calculator. So what I'm going to do is I'm going to get theta by itself. How do I get theta by itself? I arc tangent both sides. And then from there, you just punch it in your calculator. So you guys go ahead and do that now. Go ahead and push second tangent -3 equals, and remember, put negative, not -3. The negative button's at the bottom. What are we getting? -71.5 something? Okay. So that would be about -71 degrees. Remember, Look at my domain and range here. I'm sorry, my range values. They don't say quadrant 1 and quadrant 2. They say from negative 90 to positive 90. So you can get negatives or positives. That's how they do it. So it goes from negative 90 to positive 90. So in this case, we're actually in quadrant 4 down there somewhere, negative 71 degrees below. All right, let's do another one. How about cosecant? Don't get angry yet. Cosecant of, let's say, 6. Cosecant of 6. You're like, okay, so why would you be angry? Well, you said we're not doing this. I didn't say we're not doing cosecant. I'm just saying I'm not doing the arc cosecant. So here's what we're going to solve it the same way we did yesterday. The first thing I'm going to do is I'm going to take a reciprocal on both sides. So that's going to be 1 over cosecant of theta is equal to what? 1 over 6. And what is 1 over cosecant of theta? Sine. And now I'm going to arc sine both sides, right? So if I arc sine this side, the sine cancels and I'm left with theta. But whatever you do to one side, you do to the other. And now we get to put it in our calculator. So you guys go ahead and do that. What is arc sine of 1/6? What is it again? 9.594, and that's degrees. So what quadrant are we in? Quadrant 1. It's barely off the x-axis, very low. All right, so that's solving trigonometric equations. So here's the point, is that when you have this sort of stuff, just arctan or arcsine or arc cosine on the other side. But if you start with one of the weird ones, convert them first to sine, cosine, or tangent so you can use the calculator, okay? So let me throw a couple at you and see how you guys do. Let's try cosine of theta is equal to, I don't know, how about 1/3? And then how about cotangent of theta is equal to 2?